This is video number 2 for sections 7.1 and 7.2, Understanding Standard Form. So now that we have really looked in depth at vertex form, we need to take a look at how the standard form of quadratic functions work. Standard form, remember, is y equals ax squared plus bx plus c. Every quadratic function can be written in both forms. They're interchangeable. Each one just communicates a little bit different information about the parabola. We've already figured out what the a and the h and the k communicate in vertex form. Now we need to figure out, well, what if you're in standard form? What does this a, b, and c tell you about this particular parabola? Well, let's take each letter one at a time. A is the easiest because it's the same thing. A is the same A in both forms. It's the only constant that appears in both. So the role of A is the same as it was in vertex form. What we learned in that lesson is that A controls both the direction and the shape of the parabola. And you can check back on your notes for more details on that. Remember that if A is positive, the parabola opens up, and if A is negative, the parabola opens down. And then the shape part, that was that wide, narrow thing. If the absolute value of A was bigger than 1, the parabola was going to be narrow, but if it was less than 1, it was going to be wide. All of that stuff that we learned in that lesson applies to this one as well. So A is very easy. Let's skip down to the C, the role of this C here at the end. This is pretty easy to figure out. Watch what happens if I insert 0 in place of x. I would get y equals a times 0 squared plus b times 0 plus c. Well, most of this stuff wipes out, right? That's just 0, that's just 0. The only thing I'd be left with is c. That means the point 0, comma c is always on this parabola. Well, hopefully that sounds familiar. If the x-coordinate is 0, you're talking about the y-intercept. Well, that's what c is. C is the y-intercept. To be specific, we can say the point 0, comma c is the y-intercept. See, this is information that was not in vertex form. You can't see the y-intercept in vertex form, but you can see it right in the equation in standard form. Okay, we've covered A, we've covered C. What about the role of B? Well, this one is the trickiest. B doesn't really do anything directly, but it is involved in helping you to determine the vertex when you are in standard form. Remember, there's no h and k in standard form, so you can no longer just see the vertex. You have to actually figure out what it is. Well, it turns out there's a really helpful formula, and I want to now show you where this formula comes from. So let me start with kind of a generic quadratic function. This is just the general standard form. If I were to draw a picture of this, of course I don't have any actual numbers, but I at least know the shape would be some kind of parabola. So something like this. Well, in the last little part, we figured out the coordinates of this point. This point right here is the y-intercept, and I know now that that is 0, comma c every time. C is always the y-intercept. Well, parabolas are very symmetrical, and hopefully you can see that there's another point right across the way here, right over here, kind of at the same height, that would also be something, comma c. I'm not quite sure what the something is. It would be this x value right here, but there's definitely another x that has a y value of c. I would like to find that other x value. Well, I can do that using algebra. I just have to go to my equation, replace y with c, and then solve for x. Let's go ahead and do that. When I write that down, I've created here a quadratic equation, the kind that we solved at the end of Chapter 6. We've only learned one method for solving equations that have x squareds, and that is the factoring method. So let's crank through the details. The first step is to create a 0 on one side. That worked out pretty nice because c disappeared from both places. The next step is to factor, and this is pretty easy factoring because I have a GCF. I can pull an x out of both terms. This is now fully factored, and the final step is to use that zero product principle, right, where I set each factor equal to 0. And then solve each part, and I'm finished. The first part is already solved. The second part goes pretty quick. I get ax equals negative b, and then when I divide, x equals negative b over a. So there are two x values that go with a y value of c. One of them we already knew about. Here it is, 0 comma c. That's this 0. The other one is the one we were trying to find. So now I know that this is negative b over a. In other words, this was the point negative b over a comma c. All right, you say, what does this have to do with anything? Well, remember, I'm interested in learning something about the vertex. The vertex is right here. And again, hopefully you can see from the symmetry of the picture that the h part of the vertex, the x coordinate of the vertex, is exactly halfway to this other spot that we just found. In other words, the h is simply half of the negative b over a. Half of in math just means multiply by 1/2, and when I do that, I multiply across, I get negative b on the top and 2a on the bottom. Well, we have just come up with this critical formula for finding the h part of the vertex. It is h equals negative b over 2a. This is a formula that you really need to commit to memory. You're going to use it every single time you're in standard form and you want to know something about the vertex. And just kind of a warning here, the view and example problems in my math lab are not doing a good job of showing the use of this formula. They really do this a complicated way, using this symmetry stuff every time. Don't do that. Don't follow that example. You should be using this formula every single time you're in standard form and you want to find the vertex. You say, what about the k? I mean, that's a nice formula that tells us about the h, but how are we going to get the k part of the vertex? Well, you don't need any special formula for that. You have to remember that the h is just an x value. Here's the vertex. We now know that the vertex is h comma blank. Well, if you know the first part, if you know the x-coordinate, all you have to do is go back up to your equation of the parabola and plug in that h value everywhere you see x, and the y value that goes with it is the k. So to summarize, we're saying that in order to find k, you just take your h value and substitute it in for x in the original function. In our next video, I'll show you how to use this formula and this idea for finding k in an actual example problem.